In March 1986, it got within 600 kilometers of the comet's nucleus. During this time, the 15-kilometer-wide comet was ejecting 3 tons of material each second from 3 major vents, mostly water and carbon monoxide. Giotto endured over 12,000 impacts from cometary debris until one violent impact knocked the craft off course and destroyed its camera. Since that time, a number of spacecraft have made more cautious approaches to less active comets. They have managed to collect some comet dust and even deliberately crash into a comet to release materials. The most difficult and dangerous comet mission since Giotto has been underway since 2004. In March of that year, the European Space Agency launched the Rosetta spacecraft, which will rendezvous with its cometary target. Excitingly, Rosetta carries a smaller robot explorer, Philae, which is due to actually land on the comet's nucleus. Explorations of asteroids and comets with their apparently ancient composition will hopefully tell us more about how the planets were formed over 4 billion years ago. More robots have been destroyed trying to explore Mars than any other planet. The Russians have been particularly unlucky. In 2011, their most sophisticated Mars robot got no further than Earth orbit. It had been designed to land on the surface of the Martian moon Phobos, a possible site for an early manned mission. Despite all the difficulties, there are many robotic explorers from the US and Europe at work. In 2012, the US successfully landed the largest and most sophisticated rover named Curiosity to begin a new era in Mars exploration and eventually allow the first manned Mars landings. Manned flights to the largest planet in our system, Jupiter, are unlikely for perhaps a century or more because of its dangerous radiation environment. Even robots need to be especially hardened to survive here. The Galileo spacecraft, which orbited the planet for several years, often lost data and even had electric arcing between some of its components. It's a deadly place for robots and humans alike. However, some form of life might exist nearby on Europa, one of Jupiter's giant moons. Its icy surface is believed to cover an ocean with more water than all of Earth's oceans combined. Looking like a giant propeller, Juno uses new high-tech solar panels to generate electrical power. By the time sunlight reaches Jupiter, it is 25 times weaker than on Earth. Launched in 2011, Juno will enter orbit around Jupiter. It is expected to revolutionize our understanding of the atmosphere, environment, and origin of this giant planet. At twice the distance of Jupiter, Saturn, second largest of the gas giants, presents its own challenges for explorers. Since 2004, Saturn has been orbited by one of the largest and most sophisticated robot explorers ever made. The size of a minibus, the Cassini spacecraft has been studying the giant planet and its 60-plus moons. Cassini's instruments have revealed Saturn's spectacular ring system to be amazingly complex and constantly changing. If they were around Earth, the rings would stretch almost a third of the way to the moon, yet they are only 10 meters thick. These trillions of tiny ice particles are constantly being sculpted into different positions by the effects of moons both large and small. One moon, Enceladus, is believed to be filling a ring with icy material ejected from water geysers on its surface. Enceladus and the giant moon Titan are the two most fascinating in Saturn's grid. In 1980, Voyager 1 sacrificed its chance to visit the more distant planets to close in on Titan, a moon bigger than the planet Mercury. Voyager's cameras found Titan's surface hidden by a dense atmosphere. But other instruments revealed that this atmosphere was largely nitrogen topped by dense hydrocarbon smog. This means Titan was like the Earth of 4 billion years ago, but frozen in interplanetary deep freeze, a prime target for Cassini. Not only could Cassini see through Titan's clouds with infrared and radar, but it carried a lander. In December 2005, the European Space Agency's Huygens craft spent over 2 hours drifting to the surface of Titan. Transmitted back to the Cassini mothership, its pictures were startling Earth-like views: rivers, mountains, coastlines. However, these are rivers of methane and mountains not of rock, but of rock-hard ice. Huygens soft-landed and sent back a panorama of its surroundings. This is a recreation of exactly what it saw: a floodplain covered in pebbles, rounded by a rushing torrent of methane hundreds of degrees below the freezing point of water. Yet this world could be a time capsule to transport us back to the birth of our planet and the first stirrings of life itself.